But today we're going to review, and that's the key. Is we've already talked about how to do this in class, but we're going to review how to solve linear equations. And remember, the linear equations are anything that look remotely like y equals mx plus b. Remember, we've solved those, we've graphed them before, or they can look like something like ax plus by plus c equals 0. Where any of these numbers, these letters can actually be numbers. So the M could be a 3 and the B could be a 6. Maybe even the Y can be a 7. Instead of having an A, a B, and a C, we could actually have something a little bit more like a 10, a -5, and a 7 here. So anything that looks remotely like this are called linear equations. We've solved those before. To solve them, remember, that was a little bit different than when we were simplifying them, because when we simplify, we weren't necessarily getting a solution, a one answer, something like x equals 7. That's what happens when we solve it. When we actually are trying to find a solution, that when we sub it back into the original equation for x, it actually makes a true statement. So that's what I mean by solving. So first we're going to start with a one-step, then go to a two-step, and then a multi-step. And so we've already done this in class, but like I said, this is a little bit of a review. So for the first one, let's start with an example that I'm actually going to take straight out of our intensified algebra material that we were working with earlier. So let's go ahead and start with the 8 minus 3x equals -7. So I'm going to write that down. 8 minus 3x equals -7. And I'm going to go through and solve this, but what I'd like you to do is I'd like you on your own to try to pause this video and to try to work through it on your own. Like I said, this is review. We've already walked through the processes. We've looked at how to do it by graphing, using tables, or algebraically. So this is the different methods. And remember, you can use Desmos to help you with the graphing method. But what I'd like you to do right now is to pause this video, solve this linear equation, example number 1. I'd like you to solve this on your own and then press play in a little bit and watch me do it. I'm going to be using the algebraic method, but I can also show you the graphing method in a moment. So pause. Okay, now you're probably back from the pause, and so hopefully you've had your solution. First, I'm going to show you the algebraically, and then I'll go back and show you the graphing method. So to use the algebraic method, remember what we were trying to do is using things called inverse operations. Oops. And so the inverse operations, remember, inverse means opposite. And operations were the PEMDAS, P-E-M-D-A-S. So the inverse operations meaning, for instance, if you notice in this equation, we are going to undo this 8 here, and remember that 8 is being added. So this is currently showing us addition. And so using the inverse operation, instead of using addition, we're going to use subtraction. So what that means is we take the 8 minus 3x, which is currently on that side of the equation, we're going to subtract 8, then we have a -7 minus 8 here. So you'll notice that I use the inverse operation here and here to undo that positive 8 on top. And we've talked about how there's a little plus sign here, we just don't usually see that. So when we go through and simplify this equation, you'll notice this 8 and this -8 here create something called a zero pair, which means they cancel out because they turn into 0. So we're left with a -3x equals -7 minus 8. So when we multiply or add those together, or combine those together, or subtract those together, all meaning the same thing, we end up with a -15. So then the next step would be to figure out, okay, what do we need to do here if we're going to undo this -3? And remember, this is one of those mistakes that's easy to do, those flick on the ear mistakes. Those things that are just really easy to do without thinking, where you can look at this and say, oh, we have a subtraction. But is this subtraction? It's not, because we'll remember that there was a hidden little multiplication symbol between the -3 and the x. And so what we need to actually undo is the multiplication. And so the inverse operation for the multiplication is actually going to be using division. So we need to divide both sides by -3, divide both sides by -3 here. And so the negative 3 divided by negative 3 turns into a positive 1, because anything divided by itself is 1. So on the left-hand side, we are left with an x. On the right-hand side, we have a negative 15 divided by negative 3, which turns into a positive 5. And that's your solution using an algebraic method. Now, to use the graphing method, you'll notice that if I go to my computer, you can do this from a computer or a smartphone, and you type in desmos.com, which is a free access from any computer or smartphone. You click Start Graphing. Remember, the way that we talked about it is we took the left-hand side of the equation, which was 8, let's see, I have to look back at it, minus 3x, and that was the left one, which we called y1. And then we took the right-hand side of the equation, which is y equals negative 7, and we looked at where they intersect, and we looked for the x value where they intersect, which is positive 5. So this will show you right here your answer in this case would be x equals positive 5, which is what we found out on the computer, on the tablet just a moment ago.